Welcome to mini lesson 11.2, jumping in gravity. This mini lesson will probably be a little bit more complex than most of the other mini lessons we've seen so far, mainly because this one deals with a concept that requires a lot of what we call abstraction. And abstraction is kind of a fancy way of saying something that represents another thing and it's not real. And we're going to simulate jumping in gravity. We're actually not going to program that. It would take way too long to do such things, and technically somebody else has already done it. So you might as well just kind of, use some tools that are already out there, unless you're just wanting to go through the learning process to actually program gravity and jumping, which is more complex when you think of all the physics involved than just making something go up and down. Okay, so let's look at the program and check it out. I guess I'll talk about the learning objectives first. So you're going to simulate the jump involve manipulating the Y position on a sprite. And this is our sprite. It looks just like the other sensor, kind of, from the Anescape game. And so we're using these colors to detect the platforms on here. And then we're also going to be looking at some object collision to create the jumping, so we'll know whenever the sprite is on a platform that it can jump off of. So let's go ahead and switch to Scratch right here, and we'll click on play, and let me click on play again. Oh, I opened up the wrong file. This one doesn't have any programming on it. Let me get the right file. Okay, much better. Now we have the correct file. Now, just for the record, you get to make this file. You don't actually get this file. Maybe your teacher does. So we have a sprite on the screen that moves left and right, and it should be able to jump up and down once we get done with everything. And some things we'll be able to do is have it jump up on a platform and be able to jump off that platform. Okay, now this doesn't run perfect because we're trying to make some simple code that allows the process to take place. That was my cell phone going off. Put that on silent. So anyhow, it doesn't run perfect like maybe some of the games you've seen that are, high-level platform jumpers that come from gaming companies. What you need to understand is we're just getting the basic concepts down. The code would actually have to be much more specific if we wanted the jumping to be very, very precise. Right now we're just going for, let's get it to work and understand the main idea. Then we can tweak the details as we understand programming more and develop our skills. And just for the record, if we were to really want to make a full-blown jumping game, we could do that in Scratch. We just have to, get the details down. So you can see that we're able to jump left and right. And some limitations of this that we'll correct in the actual project for the jumping game is that if we jump left, we can actually move into the platforms. You see that happen right there? Try to time it. Okay, see what's going on with that? Don't worry about that for right now. We'll fix that problem when we get through a full-blown project. What you need to worry about is that whenever the sprite, the red bottom part of the sensor, touches the black line for the platform, you're able to press the up arrow key and have the sprite jump up and jump down. And we're able to do that with our code over here. First, this function, it just changes the X position by negative or positive based upon which arrow key is being pressed. You've already seen that before. Right here underneath the green flag hat block, we set the gravity Y variable to 0. Okay, so that's going to be the variable we use to control our gravity movements. Now this is where all the action takes place. So we'll have our start method. Whoa, not start method. We'll just call it our start function. Okay, so this function, when it receives the broadcast message called start, which comes from the stage right here. Okay, so we do have a piece of code on the stage. And you're thinking, well, why don't we just put that on the sensor? True, we could have, but I also want you to get used to setting up your stage as kind of like a management type area where you can send out all the broadcast messages to all the other sprites if you're trying to execute some sort of general action within the program. So that's what I want you to get used to. Okay, back to the sensor. So we'll show the sprite, tell it to wait 0.1 second. We're just giving it a little waiting time to make sure everything else appears on the screen. And then right here is where we start making the gravity and jumping take place. So we're going to detect if the red color is touching black. You can see the sensor right here, it's red. So if it's touching black, I don't have black anywhere else in here, okay? So it's very specific on colors on the way this is made, so keep that in mind. When the up arrow is pressed, if this is true, the colors are touching, and if this is true that we press the up arrow, we play the sound jump, and we set gravity y to 7. Okay, let's say this happens as true. Our program's running, I press up, and the sprite jumps up. How's it jump up? I'll show you. Okay, so this actually takes place once all these events are true. Okay, let's skip down to where something else takes place. So now that we've had this happen, we don't worry about this else. However, this else doesn't take place either because this was true right up here. Okay, so this else is automatically skipped as well. Next, the function comes down to change y by gravity y. So we're going to change the y by the gravity y value, which is set to 7. So y is going, and it's in a forever loop, keep that in mind. So this is going to keep getting called over and over again and pushing the sprite upward into the air. Now you notice it slows down and comes back. How's it do that? Okay, well here's how. I'll show you in a second. But first let's look at this right here. So this if condition, if yellow is touching black, what that's doing is that's saying if our sprite is underneath a black barrier, it's going to force it down automatically so it can't jump up through the sprite. Okay, that's a similar technique that we would use for the sides as well, but we'll deal with that later. Alright, so anyhow, let's figure out what makes it go down. So we press the up arrow when red is touching black, which allows us to set gravity y to 7. We keep changing the y position by the value of 7. However, this is a forever loop, so once the program goes through the loop once, it comes back to the top. And since we have just changed the y position by positive 7, the red is no longer touching the black, so this is impossible, it cannot be true, so we default to the else section. In the else section, we say, oh, if gravity y is greater than negative 7, which it is because we just set it right here to positive 7, if it's greater than negative 7, we're going to change gravity y by negative 0.25. And once that executes, we come down to here and we change y by the value of gravity y, and we keep going through the code. And it's going to keep defaulting down to this particular if condition within this else. Okay, it's going to keep coming here because this is never true because it's moving upward. As you can see, it's going up, and as it's going up, this is never true, so we're going to keep coming to this if condition, and as long as gravity y is greater than negative 7, we're going to keep subtracting negative 0.25. And what happens is, over time, and this happens very quickly, we keep subtracting negative 0.25 from gravity y, and there'll be a point where gravity y actually goes from a positive to a negative value because we keep subtracting negative 0.25 from it. And once it gets to a negative value, that's what causes the sprite to start coming downwards, okay? Because we start changing the y position by a negative value that has been put into the gravity y variable with this piece of code right here, okay? And that's what pulls it down. Now, watch this. It goes up and it comes down, and it comes down under control. And I can give you the values of gravity y right here. You can look at the values as we press the buttons here. So you can see it's going up and it's coming down. And if you looked real close, and I'll do it again, look for the lowest value of gravity y. And you'll see it probably gets like to negative 6.5. Let's say we get real high and we come down. Okay, it caps at negative 7, or I guess it bottoms out at negative 7. So we never let the gravity y get below negative 7. Okay, let's say that we didn't have this in here. Let's just pull this out. Let's just say we just keep changing gravity y by position. Now watch what happens. So let's run the code. I jump up. Okay, no problems there, right? Nothing's wrong. Let's get to the very top. Let's see what happens when we get real high up. Okay, so I come down. Now you probably didn't see it, but the gravity y position, I can't stop it fast enough, but you can see it pulled the sprite through the platform because we got so high. And that's what happens if we don't control this. Let's say on my platform we have a scenario where, let's move the platform actually down a little bit so it's not so right there. So I'm going to move it down even further. Okay. And let's come back over here and run our program. Remember, we've adjusted the code. Whoops, I forgot that it does that. Okay, I need to come over here and get off that sprite. So it's adjusting the image while the program was actually run. So remember, we just removed that if condition that doesn't stop gravity y from going below -7. So right here, when I come up, all right, I'm going to fall down, and you can see that it gets down to like -9 point something. That's not much of a big deal, but if I was to change this value to say -1, okay, and let's start it over, you can see that the sprite can't jump as high, and if it fell down from one of these tall platforms, say right up here, boop, it's going to go completely through the platform because it's changing at a negative value that's very, very great. So this value doesn't seem like a big deal. This piece of code keeps it under control and helps it from getting out of control. And when you experiment with your code, you'll notice sometimes it does get out of control. So just keep that in mind, that this little piece of code can help you keep your sprites under control. Now there may be a scenario where you want it out of control because it's kind of cool and fun, but for now we don't want that scenario. So that is the program. Not too complex, but it's got some difficult concepts if you're new to programming. Let's go back to our presentation. So right here, I'm going to pause the video and let you go through and read through this material. But we're working with physics. This is physical science right here. Now it's not true physics, but we're going to kind of simulate the physics. And I go through a piece of code that changes the Y position by using a repeat block going up and down. Now the code we use is much more complex, but this is kind of a simple way to get a sprite to quickly jump up and down. If I was you, I would pause the video and go to Scratch and play this and just check it out and see what happens. You'll notice the results are kind of, they're not very good. It's not going to make a good jumping game, but it does make a sprite look like it's going up and down. And again, pause the video, go through, look at these terms, because we are looking at Newton's law of gravity, you know, pulling objects back down. So whatever goes up must come down. Force is a very important concept to understand, okay, especially since you're dealing with gravity. And it's good to have these ideas in mind. Now, granted, we don't go through and program the force of the mass of the object and its acceleration. We could assign a mass to the object, but again, we're going to get into some more complex physics that we don't really want to get involved with right now. And let's see. Yep, so our program simulates jumping just by letting it go up and down. Okay, let's go to the next. Now here's a cool little graph I made in Excel. It's pretty nice, isn't it? You should check out my Excel programming skills. That's actually one of the first places I really blossomed out as a programmer. Okay, so our program is going to simulate gravity due to oh yeah, I already talked about that. There's our code. We already walked through that. You got a general idea. This function right here that I set up is a simplified function of what you saw over here. Okay, this is the complex one that you'll be making. This one's a little bit more simple example, and what I did with this is I wanted you to see the data values in this little data chart right here as we cycle through the forever loop and how we change the gravity Y position. So let's look at this. So cycle 1, gravity Y is at 0. Okay, the reason is because we set gravity Y to a value of 0. And this happens presuming that the up arrow has not been pressed. So start button runs, gravity Y is set to 0 because we haven't pressed the up arrow, and the sprite is at position 0 on the Y axis. Okay, and we don't change it by anything. Now let's presume that the up arrow has been pressed. Okay, so the up arrow has been pressed. Now gravity Y on the second cycle right here, and we're talking about cycles like how many times the computer goes through the loop. Again, this is slowed down. Okay, the computer would actually go through 8 cycles, probably faster than we can say the word 8. So gravity Y is set to a value 3. So gravity Y is 3, and the Y position of the sprite is now 3. And you can see this chart right here where I show you it in a line graph that shows its movement upward and down. Now this is just representing the upward movement on the Y-axis, not actually representing true movement, okay? Because I just want you to see over time how it moves up and down. Okay, next on cycle 2, gravity Y is now 2 because we subtract 1 from right here, just like the other code you saw. because if gravity y is greater than -3, which it is because I got set to 3 right here, then we're going to change gravity y by -1, and you'll notice its position is now 5, okay? Because we subtracted 1, which is 2, but the 2 is still positive, so we added it to its current y position, which moved up to 5. Next cycle, gravity y is now 1, but it's still moving upward, which gives it a y position of 6. And then on cycle 5, since we subtracted 1 again, it's now a value of 0, and it's at y position of 6. That's what causes the sprite whenever it went up and it kind of pauses a little bit. You kind of see where it gets up to the right about here, and then it kind of slows down. It almost looks like it's not moving. Okay, that's happening because of this data value right here. Okay, because gravity y is at a 0, it sticks on that y position, and then again, this is still cycling through. This is still true, so we're still subtracting 1, and then it makes gravity y -1, which causes it to go down, and then it starts subtracting from the y position. So that pretty much wraps up this lesson here. You'll be programming a stage, just a simple piece of code inside there, platform. I can't remember if anything's on the platform. I don't think so. And then there's the sensor sprite. Actually, I think on the platform you go through, let's check it out real quick. Yeah, platform, you're just going to simply set the value back 10 layers, or not the value, but the sprite back 10 layers so it falls behind everything, and then put in its XY coordinates. A lot of people forget to do these things whenever they're programming some sort of sprite that just stays on the screen. It's not a big deal until the sprite gets moved to a position or starts having some weird interactions that you need to make sure that you do program in its XY coordinates. Even if it's not going to move, you don't think it'll move, just go ahead and put the XY coordinates of the sprite so that way you know where it is. And here's a quick way to get the XY coordinates for a sprite. It's kind of a bonus feature right here. Let's say we have a sprite on our screen. Let's put the ball soccer. I don't know why I call it soccer ball, but whatever. So we have our sprite right here, okay? The ball soccer. And it's at 104.33. Here's a quick and easy way to get its coordinates on there. So you click on motion, and voila, the GoTo already has its XY coordinates in there. Piece of cake, right? Let's say I changed my mind. I want it over here. I look, it's -181.32, so I can come and type it in. However, there's an even easier way. Click off the motion category, then come back to motion and select it, and you'll notice the GoTo block right here has updated its XY coordinates with the new ones, and you can pull that out, and you can just put this right here, and now the coordinates are updated. And that holds true for a lot of these other XY coordinates for, actually not a lot of them, just the other one is the glide, okay? So that's a quick and easy way to make sure you have the coordinates for the sprite where you want it, and it just makes it a little bit easier on you. So just remember, wherever you want your sprite, say I want it right there. I wonder if the black will interact. It should. So this automatically, hey, it updated on its own. I guess Scratch changed that. You used to have to click on and off. Now it automatically changes it. So good job, MIT. I'd buy you a cup of coffee if I, you programmers up there. So the XY coordinates automatically update, and there's our soccer ball. Oh, I forgot I put it over here. No big deal. You get the idea of how to quickly put the sprites in proper XY coordinates. Okay, we'll see you in the next video.